Welcome all, welcome to this lab of Object-Oriented Programming 1. Today we will continue with your GTU programming list. Today we'll be starting with program number 15 and we'll also see program number 16. Let me show the disclaimer, then I will start the session. Okay, so going back to our programs, starting with program number 15. So this is our program number 15. The definition that has been given over here is write the bin to deck, that is binary to decimal method to convert a binary string into a decimal number. Okay, so see, the method name is given and the method signature is also given. It takes a string variable, so it should be something like this, string, and there should be no space over here. Okay, so what is given? Bin to deck, that is binary to decimal. Method name is given, this is the method name, and these are the parameters. So there is only one parameter or one argument, that is of type string, and the name of that argument is also given. So the method signature has been given, and the aim of the method is to convert a binary string into a decimal number. Okay, and we have to implement it such a way that it can throw a number format exception if the string is not a binary string. So see, if we talk about binary strings, binary numbers, then it may be something like this. This is 1, okay, then this binary number 0010 is equivalent to 2, and if you say 0011, then that is equivalent to 3, and if you say 0100, then that is equivalent to 4, right? In this way, suppose you say 0111, and that is equivalent to 7, okay, 1000, and that is equivalent to 8, and in this way the list goes on. Okay, in this way the list goes on. Okay, now these are binary numbers, right, and these are decimal numbers. Okay, so our input will be binary number, this will be the input, and our output will be this decimal number. Okay, that is the output. The decimal number is the output, input is binary number. Okay, and what we have to do is we have to calculate the decimal number out of the binary number. And one more thing you have to remember, binary numbers is entered as a string. If you can see over here in this method definition, it is asking for a string, not a number. Okay, so let's see how we develop the logic for that. Okay, so check this out. There are basically two methods in this class. One is the main method, another is the bin to deck method. Okay, what happens in main method? Let's check. In main method, that is this one. First, we are creating a scanner object, okay, to read input from the user through the console using keyboard. Then we ask the user to enter a binary number. Now user enters the number, but that number is read as a string by this input.next method. This next method reads a string, and that string is stored over here in this string variable called as binary number. Although it is called as binary number, it's a string. Remember that thing. Okay. Now, once you have stored the number, let's suppose that user enters some number like this 0010. Okay. Or let's say 0011. Right. So what happens is this string, this actually number is read as a string 0011 in double quotes. Okay. And that string is given to this bin to deck method by calling that bin to deck method and passing the string variable to it. Okay. And whatever it calculates, it returns, let's say, an integer number into this deck number. So what does it return? What should it return? Obviously it should return a decimal number. Here the decimal number will be basically an integer. Okay. And then we simply print it out that the decimal number is this particular decimal number. And let's suppose that while this bin to deck was executing, if at all any exception occurred, then it would throw a number format exception, due to which the control will jump directly to this catch, because this bin to deck is put inside the try catch block. Okay. So here the number format exception would be caught, and here we will display that this is the exception that has been occurred. Okay. So now let's see what happens when the control goes from this, control goes to this bin to deck method, right? Let's go over there. So see, up till now in main method, the execution was like this. As soon as this method is called, right, the control goes from here to this method, and after this method finishes, it returns an integer. So that returned value is given to this decimal number variable. Okay, and make sure, see, this main method is a static method, we know that, right? So we have kept this bin to deck method as also as static, so that it can be directly called without creating any object. Here you can see this method is being directly called. Okay, directly inside main method. Okay, because main is also static, so it can call another static method. Okay, now let's see what happens in this bin to deck method. Okay, when it receives a string something like this. Okay, we open up this method. So in this method, what happens is basically the string 0011 gets passed over here, right? As soon as the control enters over here, first we declare a result variable equal to 0. Then we start the loop from I equal to 0 up to the length of the binary number string, in fact. The length over here is what? Length is 4, right? So this is and write it like this. This is 0011. Let me write it over here. 0011. This is index 0, this is index 1, this is index 2, this is index 3. Okay. So see, how do we calculate? Yes. How do we calculate the decimal number from a binary number. How do we do that? So basically, what we do is we take each character from this particular string, right? Or we can say we take each digit from this number and accordingly multiply it with that much, that power of uh, 2. So see here, for example, if this 1 is multiplied, so now here see you have to consider in a reverse way. Although these are the indices, while considering, while putting this formula, you have to assume the indices to be something like this. Let's say this is 3, this is 2, this is 1, this is 0. Okay, that's what you have to consider. This is how you have to consider. Okay, although the indices are like this. So check this out. How do you do the formula? What is the formula? Here it is 1 into 2 raised to what? 2 raised to this particular number. So it is 2 raised to 0. Then this thing is being added. This thing is being added. Okay. This thing gets added to, again you multiply this 1 into 2 raised to what? 2 raised to, this number is over here is what? Number over here is 1. So you use that as 1. Similarly, you multiply this also. Even though we know multiplying anything with 0 becomes 0, still we do it. 0 multiplied by 2 raised to, what is the index that we have to consider over here? 2. Here we say 2 raised to 2. Then we have what? Then we have then we have 0x, again we say 0 multiplied by 2 raised to what? Over here it would be 8. If you see the result of this expression, you see the result of this whole expression, okay, it will be something like this. 0 plus 0 plus 1 into 2 raised to 1 is 2 plus 2 raised to 0 becomes 1, right? This is 1 only. So this is equivalent to 3. Obviously, this number is equivalent to the value 3, decimal value 3, right? Any confusion in this? Then please do let me know. Okay. So, see, this is how we go ahead. Okay. That's all right. Okay, so now what we will do is, in this method we have to put this logic. Okay, we have to implement this logic. So how do we implement this logic? Check this out. We start the loop, start the for loop. Okay, with I equal to 0 to the length. Okay, so I will basically go from where? I will go from, value of I goes from 0 up to 4. Sorry, less than 4, that is 3. Okay, so you can see the indices are also considered to be 0 to 3. Okay, so how, since we know that loops goes in this direction, how will you make it go into this direction? Yes, so either we start the loop from the end, okay, end of the length, either we start the I from the end of the length, or what we do is basically, but if we start even from the end of the length, the index would be 3 only. We don't want this index 3 to get multiplied, to get become the power of 2 and get multiplied with 1. No, we want from here, start from the end, and the index should be of the start only, that is 0, that is this one. So how do we do that? Take that out. So we say binary number dot caret. First we extract the character. First we try to extract the character one by one. So first we extract this character, then this, and then this. Okay. So first we extract the character at which location we want, this particular location, right? So we say binary numbers length. What is the length? That is 4, right? Minus I minus 1. So what would this be? This would be minus, what is value of I right now? I is 0. What is value again given in that equation? That is minus 1. So this equals to 4 minus 1, which is equivalent to 3. So you can see that we got this index number 3, right? Where, sorry, we got the character number 3. We got the character at location number 3. Okay. Understand? What did we get? We got the character at location number 3. Yes. How? See, again I will tell you. Binary numbers length minus I minus 1, that is the equation, right? And what is the value of I? And we'll say what is the value of char at. Okay. And then we'll also say the current bin value. We'll call it a CBV. Okay. Current bin value. What will be the current bin value character? Now, here what we do is, here basically we start with I equal to 0. But now if you see this equation, then this equation says that binary numbers length is 4 minus value of I is 0 minus 1, which is equal to 4 minus 1, which is equal to 3. So you can see the char at will have the index as 3. And if you see the index 3, the character at index 3, that is 1. So the current CBV will be character 1. See, it is character 1, not number 1. Okay. Now what we do is we compare it with 0 and 1. In the next statement, we use if to check whether the number that we have, or whether the character that we have extracted is a 0 character or is it a 1 character. If it is not any one out of these two, right, then obviously we'll have to throw a number format exception. For example, if someone would have entered the number like this 0, 0, 1 and 2, so this 2 is invalid. It's invalid in binary numbers, right? So we cannot take it as a what binary number. So that's why we throw an exception here. Given number, by saying given number is not a binary number, and display that binary number also. This is the message that we pass. Okay. So now in this case, what happens? Is this true? No, that's not true. Basically, we have character 1 even with us. So none of this, basically this condition does not evaluate to true. So that's why the control does not go inside the if statement. It goes to else if part. And here it checks what is the value. Here we simply check if the current bin value is equal to 1, then what we have to do is check this out. We have to say result equal to, what is the value of result right now? Result's value is 0. So we say result equal to result plus convert the integer of what? Match dot power 2 comma what is the value of I is nothing but the index. So value of I is 0, right? So this is equivalent to saying 0 plus 2 raised to what? 2 raised to 0, which is equivalent to saying 0 plus 1, which is equivalent to 1, right? So this 1 goes into the result. Okay, 1 goes into the result. That is the first iteration. Okay, that is the first iteration, and now the result value is 1. Okay, so we'll put on the result value also somewhere. Okay, so this was caret was 3, and here the character was 1. And the result value in first iteration was 1. Okay, and basically i's value was 0. Okay, now in the next iteration I gets incremented by 1, right? So the I value becomes 1. Okay, and now according to this particular evaluation, now this is not the case. Now what will be the case? The length of the binary number is 4 minus what is I? I's value is now 1 minus 1 is there. So this is equivalent to what? 4 minus 2. So this is equivalent to, the answer is 2. So the char at location 2. Char at which location? Location 2. So what is the character at location 2? That is also now 1. You can see over here the location 2, index 2's index 2's digit is 1. So here again we get 1 as a character. Then we check whether the current bin value is not equal to any of these two, but no, that's not the case. Current bin value is equal to 1. So here we go to this else if part. This evaluates to true. Current bin value equal to 1 evaluates to true. So we again calculate the result. Now what is the value of the result now? Result is already 1, right? Plus we say plus int maths dot power, and here we say 2 raised to, what is value of I? I's value is 1, right? So this is equivalent to saying 1 plus 2 raised to the power 1, which is almost equivalent to 1 plus 2, right? So when you say 1 plus 2, this becomes what? This becomes 3. Okay. Now this 3 goes where? When the value of I was 1, the result became what? The result became 3. Okay, so this 3 goes to the result. Okay. Now, if you consider the next iteration, see after this again the next iteration of for loop starts. Okay. And if you see these, now what is the value of I? Value of I is now 2, right? So if we consider this formula, then it becomes 4 minus 2 minus 1, which is equivalent to 4 minus 3, which is equivalent to 1. So if you see the character at index 1, that is this, that is 0, right? Although the condition is not false, although this is not, sorry, true, control does not go over here, but the control does not even go over here. Why? Because here the current bin value now is what? 0. The current bin value is 0 and not 1. So that's why this result does not get calculated in this iteration. Okay. Then again it goes and so again it goes ahead, right? And same thing happens here. The thing is something like this: 4 minus 3 minus 1, which is equivalent to 4 minus 4, which is equivalent to 0. So if you see the character at 0th location, that is what? 0. Right. So see here the character was at location 1, which was nothing but 0. And you similarly, if you consider another iteration of I, to consider this another iteration of I, there is the last iteration. There the value of I is what? 3. Okay, and the character would be at location 0, which is nothing but again character 0. Obviously this result does not get calculated because the current bin value is not equal to 1. This is current bin value, which is 0. So in both of these cases, this result does not get calculated. So in the end, what happens? As soon as the control comes out of this loop, it returns the result value, which is nothing but the last value is 3. And you can see this 0011 obviously is equivalent to the number 3. So result 3 is returned. Okay. So what happens? Here we print. Let me run this out and let me show it to you. Here it says please enter binary number. So it says 0011. The output should be 3. Check this out. Suppose I say 0111, it gives me number 7. If I say 1000, it gives me number 8. See that? I say 110011, it gives me 110011, it gives me number 51. Okay. So now let's if you want to see how this behaves, let's check it out digitally. Let me debug it out. Okay. Now let me do one thing. See, I have uploaded this on the repository. Try it out. Okay. Try it out and tell me whether you are able to run it or not. Give me the link of the repository. Please go ahead, try it out, okay, and do let me know. Okay, Rajkumar, you can share the screen and show me what you've done.
सर अभी लैपटॉप से कनेक्ट करते हैं सर, 2 मिनट।
Yes, what?
सर मोबाइल से कर, लैपटॉप में सर किए हैं तो वो अभी कनेक्ट कर रहे हैं सर, 2 मिनट टाइम।
Okay. Okay, Rajkumar, I can see your screen. Go ahead. You can mute yourself, any one of the screens. Okay, I can see you can get the output. That's good, very good.
स्टॉप कर दे सर।
Anyone else wants to show the screen? Yes, guys. Okay, Man is asking what is the use of catch here. Good question, Man. So see, in the if you see in the statement itself, it was told. If you see the statement, there itself it was told that implement the method to throw a number format exception if the string is not a binary string. Okay. So what happens if you find any other number other than any other character other than 0 or 1 inside this string? So you should throw a number format exception. Okay. You could have thrown your own exception also. Let me show you that example also. So see over here, it asks me here it asks me please enter a binary number. Okay, so I say 001, sorry 0021. Let's call it 21. I enter. So it says what? exception occurred. Given number is not a binary number. See that? So you can give your own message, your own customized message if you find that this is the condition. Okay, now we know the condition that it should not have any decimal number inside it. It should have only have binary numbers inside the string. Okay, that is zeros and ones only. Okay. You got the point? Why we are using try catch? Yes, man. Good. Anyone else wants to share the screen? Yes, anyone else wants to share the screen or not? Please let me know. Okay, Rajkumar, I think try and catch both are needed together only, right? I hope you know that. Try catch are used wherever we think that there will be an exception generated. We know, see, this throw new number format exception, this statement is placed where? In this method, right? In this static method. So if you don't declare that it throws a number format exception, then we need to put this into try catch block. Let me show you. If I remove this, and then if I try to run it, it gives me problem. This runs an old file, not the current one. Okay. So this would give you compilation problem. Although the thing that we are throwing, right, is being caught over here. So that's not an issue. But if we don't put this try catch, that will surely give us error, because here we are declaring that this method can throw a number format exception. When we write this throws number format exception, we are declaring that this method can throw this number format exception. There is a possibility by saying can. Okay. So this method has to be called only in the try catch block. Check this out. If I comment this try catch block out, I comment out this try catch block, right? See, this already throws number format exception. Now see, this will also run right now. Here, what is it? Let me run it. Please enter binary number. This also runs right now. If I set 2-1, it gives me an exception. Exception in. Now see, why it allowed it to compile? Because this number format exception is a type of runtime exception. And runtime exceptions are, if you don't put it in, in try catch block, then it's allowed. Okay. So even if we don't put this in try catch block, right now it is allowed. You see that? So, but for our safety, we put it into try catch block so that we don't get this kind of message. Okay. Got it? You can even say error occurred. You can even say error occurred. That would be a good message. So if now I run this and put here 0021, it says error occurred, given number is not a binary number. As simple as that. Got this? Okay. So I hope you people know why we use try catch blocks. Okay. So let me show this by debugging it. Let me show it to you by debugging it. I'll say debug, and before debugging, what I'll do is I'll put the points over here. Okay, check this out. What I'll do is I'll say binary number, enter binary number to be 0011. So check this out, how this runs. When I say enter, here the control has come. Okay, at this line the control has come. You can see the line has been highlighted, right? It means right now, and here you can see the debug console has been given, debug control has been given to us, right? So what is the binary number entered? You can see if I bring my cursor over here. Okay, let me put it over here, the cursor over here. Check this out, the number is 0011. That's what we have entered, right? So when I say step over, the control goes to this bin to deck method. Here the result is declared. Result is right now 0. You can see over here, it's the result value is what? 0. You can see that the value of the variable will be displayed when I take the cursor on top on it. Okay. Now I equal to 0 will start. What is this binary number dot length? What is its value? Its value will be 4 right now, right? So we can see now I has been declared to value 0. Okay. Then if we consider this whole thing, right? This whole thing will return us what? The last last character in this current string right now. So as soon as I say step over, see the binary number is 0011. Remember this thing. Binary number is what? Binary number is 0011. That is the string. And what is the first bin value we have got? 1. You can see 1 has been there. Right. Now, as soon as we get 1, okay, as soon as we get 1, we now check in the next if that whether current bin value is equal to 1 or 0. Yes, it is. So if it is not, then throw a new number format exception. So I run this. Here it goes. Now it checks. Yes, this is true. So it goes inside. What is the value of result? Result value is currently it is 0. And now if I compute this, the result value would have become what? You can see it has become, the result value has become 1. Right. So as soon as it finished this, the control went into another iteration of for loop. Now the I value will become 1. Check this out. If I take my cursor on I, it says value is 1. See that? Now again, out of this binary number, we have already got 1, so we get second one out of it. Check this out. The current bin value is 1. You see, that is the character value. So again, it will not throw an exception, but will go over here. As soon as I say next, it goes there. That is true. It goes inside if statement. You can see that this statement is inside the if statement, and that is being executed currently. Right? Control is over there. And as soon as I say step over, I get to see the what is the result value. Result value is 3. Now in the next iteration, we get the current bin value as 0. Check this out. It is 0. Right. So It does not go inside this if. You can see it does not go inside the if. And now as soon as it jumps out of the loop, what is the value returned over here from the result? P. Okay. What was the string, binary string? Yes. The binary number string was basically binary number was 0011, right? So as soon as I say go ahead, control comes back to this position from where the method was called, and this decimal number is assigned value as 0. So here it does not even go to catch, we don't throw anything, so it directly goes out, and that's it. And here you can see the output, decimal number is 3. Okay. And if we again debug it with some value that is not valid, so I say over here what 0, let me give it as only 2. As soon as I enter, it goes over here, the binary number is, you can see string 2, right? So next it goes over here, result value becomes 0. We start with I equal to 0 to number length is 1. What character do we get over here? We get the current bin value to be what? What is the current bin value that we get? That is 2. Now see, none of this is this both of this will become true. Current bin value is not equal to 0 and even not equal to 1. So it goes inside. Check this out. It goes inside. Now the controller goes inside and it throws a number format exception. As soon as it throws it, check out where the control goes. Here the control goes directly to the catch, right? And the control goes inside the catch, and then here we get the output that the given number is not a binary number. You see that? So that's it. That is how we run it. Okay. Okay. Now let's go to, is this program clear to all of you? Yes. Please let me know, guys. Any more doubts in this? Okay, so now let's go to the next program, that is program number 16. Okay, check this out. What this program says? This program says that the statement says that write a program that prompts the user to enter a decimal number and displays the number in a fraction. What do we have to do? We have to write a program that prompts the user to enter a decimal number and displays the number in a fraction. Okay, so it would be something like this. Your input would be something like 2.5, and it should give you a fraction number like 5 by 2. Or it may be your number would be something like 3.5, and it may give you something like 7 by 2. right? Okay, so it may be something like this 5.7, which would give you about like something like 57 divided by 10. Okay, so this will be the input, and this will be the output. Okay, that's what we expect from this particular program. And hint, what is the hint given here? Check it out. Hint is said that the read the decimal number as a string, extract the integer part and fractional part from the string. Okay, so you have to extract this part and this part. Okay, but see, it's not like it's not as easy as that. It's not like this goes over here and this goes over here. No, it's not the case. Okay. There is some different formula. There are some different formula associated with it. So let me show it to you. So see, here basically, here we have one method main, and there is another class called rational. We have made a separate class for this. Okay. Let me show you how this works. Okay. Let me first show you the output so that you can understand the output. Then let me explain you the program. Did you guys get what is happening in the output? Yes. Do you understand what is how the program is running? Please let me know that first. Please reply in the chat box. Only one person has understood it. Is it so? Yes, only one person has understood it. Is it so, guys? Okay, let me go back. Okay, so check this thing. With this main method, we first get the scanner object. We ask the user to enter decimal number. Okay, and this a number, we can say that's a number with a decimal point specifically. Okay, and it says input.next. So it reads the number in the what? It reads the number in a in what? In the string format. Okay. Now see what happens over here is that as soon as we read it in the string format, we have to split it out. Okay. So see, for example, if the number entered over here is, let's say, 2.5, what it will do is, first we split the number. We say number dot split it on the base of a dot, and here we assume that there will be only two digits, one before the decimal point, one after the decimal point. That's what we assume. Okay, so once we split on the dot, we check whether that length of that that particular array is not equal to 2 or what, because here what happens, it gets split into number 2 and 5, so this becomes an array. This becomes an array. Okay, as soon as this becomes an array, we check whether this length is not equal to 2 or what. If it's not, then we say that given number is not a valid decimal number. Okay, and exit out of it. Otherwise, you pass that number string to this rational class, what? Constructor of this rational class is invoked to create a rational number. So a rational number will be something like this. So it will have two parts. One is the numerator, okay, and the another is denominator. These two parts will be there inside a rational number. Okay. So let's see what happens over here. As soon as this rational number, this string is converted into a rational number object, after that we output that the number in fraction is rnum.get numerator. We say get numerator method. We call the get numerator method. Concat it with a slash, and then we say rnum.get denominator. So see, you can see we get two separate values. Okay, it's not a simple number itself. We cannot represent this thing as a number. We cannot represent this thing as a number. No, we cannot store it as a number basically. Okay, so we represent these two as a different entities. Okay. Now the question is, how do we find these two numbers, right? So let's see that. Okay, check this out. In this rational class, you have two private instance variables. One is numerator, another is denominator. Okay. In this rational, inside this constructor of this rational class is a parameterized constructor. Here we are passing the number. So for example, we read the number as 2.5. So this 2.5 is passed over here as a string. Okay. So check this out. What do? We first get the index of this particular of this dot. Okay. We say number dot index of dot. So we want the index of this dot, that is nothing but the decimal position of the decimal point, right? Now Once we got the decimal position, what we will do, check this out. We say math dot power 10 comma number dot length minus decimal position minus 1. So if you see the decimal position right now, the decimal position right now is 1. This is the position 0 and this is the position 2. Okay. So if you see the length of the number is, it's a string, right? So we get the length as 3 minus what is the decimal position? That's 1 minus, we again say 1. So this is equivalent to 3 minus 2, which is equivalent to 1. We say maths dot power 10 comma 1. So it's like saying that 10 raised to power 1, which is nothing but just simply 10. Okay. So we get the denominator as 10. Right, denominator means the 10 is on right hand side of the slash. So still we have not got the numerator part, right? We calculate the numerator by using this denominator itself. What do? We convert this whole number, convert the whole number into a double number by saying double dot parse, sending the number to it. Okay. So see, as soon as you pass the number over here and parse it out, that becomes a valid double number. And now you are multiplying it with the denominator. What is the value of that? That is 10. So this results into 25. This 25 is given to the numerator. So now we have found the numerator and denominator both. 25 divided by 10. But is this a valid rational number? Well, I think this rational number can still be reduced or can be normalized. So that's why what we do is we call this normalized method. To normalize this rational number that we have got. We have got the value of numerator and denominator, but the values are not yet normalized. These values can be normalized by dividing them with a GCD. Both the numerator and denominator can be divided by a GCD, that is greatest common divisor. And then this whole fraction number will be a normalized number. So let's go to this normalized method. What happens there? Right now we have got numerator and denominator. This numerator and denominator, the variables that we have declared, those have been achieved, right? Out of this 2.5, and you can see, you can relate it. 25 divided by 10 is 2.5. That's correct, right? But 25 divided by 10 is not a reduced fraction number, right? We need to reduce it still. So how do we reduce it? So we find a greatest common divisor by calling this normalized method. Check this out, what happens in the normalized method. When the control comes over here, it directly calls this GCD method, where it passes numerator and denominator. So the control goes to, from here the control goes to this particular method. Okay. And here the number 1 is 25. Number 1 is 25. Number 2 is what? Number 1 is 25. Number 2 is 10. Now check this out. When this GCD is called, right, what we do is we first declare GCD equal to 1. Okay. and then we start dividing this both numbers with starting from 1 up to the highest number, right? So we start, we start the value of I. Let me go to GCD and num1, num2, and let me say num1. Let me start it with over here from here. I say this is I, then this is num1, this is num1 modulo I, and you have num2. This will take a lot of space, so let me reduce the space. Yeah, I is there, then num1 is there, then we have num1 modulo I, then we have num2, then we have num2 modulo I, and then we have GCD. Okay, so let me create a table for this. Okay, so check this out. The value of I will go from will start from 1. Okay, so the value of I starts from 1, then 2, then 3, then 4, then 5, then 6, and it goes up to what? Up to 24. Okay, goes up to 24. Okay, because here we say int I equal to 1, I less than num1, right? Now check this out. So these are the number of iterations that the loop takes. Okay, what is the value of num1? Value of num1 is 25, and every time it remains the same. This value does not get affected. We are not doing anything with this original value of num1 and num2. Okay. For all this 24 iterations, it is value is 25, and same happens with num2. Num2's value is 10 for all this 24 iterations. Okay, so for all this, all of this values, it is num1 is same, num2 is same. But now we just have to check whether num1 is divisible by 0 and num2 is also divisible by I, not 0. If num1 is also divisible by I and num2 is also divisible by I, then we will assign I2 as GCD. We'll assign I to GCD because that is the number that can divide both the numbers. So now see, 1 can divide both of them, right? So here this num mod I returns true, and then num num1 mod I returns true and num2 mod I also returns true. So the GCD value becomes 1. Okay, which was already 1. Then in the second iteration, can we check whether this 25 mod 2 is 0? Well, no. So this returns what? This returns false. This returns true, but one of the condition is false, and you can see here AND operator is used. So if any of the condition is false, if will control will not go into the block. So check this out, up to where it is true and up to where it is false. Here also it is false. Here it is also false. Then here it is false. Here it is also false. Here it is true, and here also it is true. Why? Because see, 25 can be divided by 5, and 10 also can be divided by 5. In each, in other cases it was not the case. Here 25 was not divisible by 2 but was divisible by 10. Here 25 was not divisible by 3 nor 10 was divisible by 3. Same case happened here also. But here 25 and 10 both are divisible by what? By 5. So what we will do is we'll basically assign the value of I, that is 5, to GCD. So the value of GCD now becomes 1. Before that, the value of GCD was always 1, as it is. There was no change in it. Okay. Sorry, I think this 5 becomes over here. Now see what happens if we go to the next iteration. Okay, this 25 is not divisible by 6, so it gives false. Similarly, 10 is also not divisible by 6, it gives false, right? And up to up to this part, if you see all the numbers, okay, up to 24, you won't get anywhere both true. Any number you take between 6 and 24, those number will not be able to divide these both. Okay, divide this both and give you the what remainder as 0. Okay, so this 5 remains as it is. The 5 remains as it is as GCD, and that's what we return. That's what, once the for loop ends over here, we return this GCD. This GCD is returned over here, assigned to this GCD value in this normalized method. We know that this GCD method was called from normalized method. So the control goes back to the normalized method and it assigns this value to this GCD variable of normalized method. Now see what happens. As soon as this GCD gets assigned, we say this dot numerator equal to this dot numerator by GCD. Now what is the value of numerator? Tell me. The numerator was 25. Denominator was 10. So it is something like 25 divided by 10, right? But what do we do? Once we found the GCD, that is greatest common divisor, we divide both the numbers by GCD. Right. So here we divided by 5. Here also we divided by 5. 25 is divided by 5, 10 is divided by 5. Right. So we can see 5 into 5 into 5 is 25, and 5 into what? 2 is 10, right? So now this results into what? This whole thing results into 5 divided by 2. Okay. This is now a normalized what? A normalized rational number. Got the point? Yes. So now we can, once this normalized method returns, the control returns over here. This controller, sorry, this one, this particular constructor has finished, and as soon as the constructor finishes, it gives that object to this rnum. So during the meantime, it is also found numerator and denominator both. Okay. So as soon as it is found, we print it out. Okay. So let me again run it, or let's debug it, and let me show it to you by debugging it. I see debug. For that I will have to put some points, right? So here I'll put, here I'll put, here I'll put, and here I'll put. Here specifically we'll put over here, here, here. In normalize also we would put some. Normalize method we'll put over here, then over here in GCD method, in for loop over here, and inside if, and inside here in GCD, and then maybe over here. Okay. So here we have to enter a decimal number, right? So I say please enter decimal number. Over there I say 2.5. I give the enter the number as what? This number is 2.5. Okay. So as soon as I enter, you can see the control has come over here. Okay. What is the number value? It is 2.5. You can see that the number value is what? 2.5. Right? We split it and let's see whether it is not equal to 2 or not, or we say step over and it goes out of this if. So it does not go inside the if. That's good. So now we call this new operator over the rational class, and I say we pass the number also to that. I say step over, it goes into that. Here we have put the point. So the number is 2.5 and the index of this would be, what is the index of that? 1. You can see that is 1. The decimal position, yes, the decimal position is 1. You can see that. Now we get the denominator first. What is the denominator? You can see it is, denominator is 10. Okay. As soon as I go ahead, I get the numerator. What is that? 25. You see, denominator is 10, numerator is 25. Okay. And then we say normalize. So as soon as I call this normalize, it goes over here. Numerator you can see is 25, denominator is 10. These two values are being passed in this GCD method. If I say next, control goes over here. GCD value is equal to 1. We start the loop from 1 to 25. You can see from 1 to, what is I less than 25. So from 1 to 24 the loop will continue. Okay. Now I say next. Now check this out. Here num1 mod I equal to 0 and num2 mod I equal to 0. Is this the case? Well, 25 mod I is 0. Yes, so it goes inside, and GCD is equal to what? GCD is equal to I, that is 1. In the next iteration, it will not go inside the if. Check this out. In the next iteration, now see the value of I is 3. It does not go. Value of I is, again I go over here, value of I becomes 4. It does not go inside if. Now the value of I would have become what? 5. So it will go inside. Check this out. It went inside, and again it assigned value of I to GCD. So if I step over, it goes to the next for loop iteration, and now the GCD value is 5. You can see, right? So I'll remove it from here and I'll say continue. So as soon as I say continue, I'll remove this also. It comes over here. It finishes the whole iteration of this for loop from 1 to 24, and in the end, if you see what is GCD, the value of GCD is what? Value of GCD is 5. You see that? So that value of GCD gets returned over here, and then we divide this numerator, which was 25. As soon as I press this, the numerator value becomes what? 5, because 25 divided by 5 gives 5, and now the denominator value is what? 10. As soon as I do this, the denominator value becomes 2. And now this gets finished, rational constructor gets finished, we get the rational object, and through that rational object we get the numerator and denominator, and we print it out. Here it is. Okay. So that's it. Try this program out. Okay. Let me remove all these points, breakpoints, and try to debug this program on your own and get to know how the control goes. Okay, since it's a big program, it's better to understand it through debugging. Okay, let me run it again and let me give some other example. Here I say 7.5. Why not there? Over here 7.5. Enter. That's 15/2. You see that? Any doubt in this? Please do let me know. Yes, guys. Any doubt in this particular program? So a bigger program, so it's but very easy. It's not that difficult. Yes, please do reply on the chat box. I don't get to see any answer, guys. I don't yet see any answers from you people. Please reply. Is this program clear to all? Have you people understood?
Sir,
Yes, man.
sir, how the GCD will work in 0.25? It will be 25 by 100 or 2.5 by 10.
Okay. So see, first thing is here we have what we have assumed, that the number will be divided into this whole string will be divided into let me run it out for you and show you. So it should be divided into two two at least two array with two elements. Okay, so if I say 0.025, so see, it gives me something like this. Okay, is this a correct answer? Tell me, is this the correct answer?
Yes, 1 by 4 is 20, 0.25.
Yes. So see, the method that it has followed is proper, but if we give bigger, right now what has happened is, see, we divided this into two values. Okay, and then it basically found out the numerator and denominator. Okay, but if you see this 0.25, right, it can be also like 1 by 4, right? It can also be as 1 by 4, right? That would be much better option, right? So here it is not able to normalize it. You see that? If we give this kind of, so what we assume is, we assume that the, that's what I told you before in this program. We assume that the number is of 2 digits only. If it's zero point 0.2, that's good. If it's 0.5, that's good. If it's 2.5, that's good. If it's 3.6, that's 3.6, that's good, right? But if you give such numbers, then I'm not sure, we are not sure that we will be getting the perfect rational number or not. This can further be actually, this further can be what? Reduced to 1 divided by,
1 by 4. 4.
right? But
Yes.
that is not happening over here. So that's what I told you before, that this particular program takes into consideration only a string with 3 digits, three
Yes.
characters. The number before the decimal point, number after the decimal point, right? So what you can do is, uh, you can further develop this program in such a way that it recursively finds the GCD. Okay, it recursively finds the GCD and checks whether the GCD is able to divide these two numbers or not. If it is able to divide, then let's divide it. Okay, got the point?
Yes.
Okay, that is the solution to this. You can try it out on your own. Okay, I have not made this much complicated, but this is a very simple program that we have made for basically a very small decimal number. Even if give a very big decimal number, it will get confused and it might give you a wrong answer. For example, if I say 1.33, something like this over here, 1.333, right? It would give you something like this. Although this is correct, okay. If
Yes.
I say like 1.6667, that's not a problem into that. See, but
Yes.
you should, in fact, you should get a proper value of a proper, what, of a proper uh, normalized. There should be a normalized fraction, right? So it's not going that deeper into that. Okay, understand?
Okay.
It's not calculating.
Yes.
Actually, this is a string, and our logic is such that it gives us like this. So maybe you may need to change the logic itself. See, here we are not using mathematical logic, right? Here we are using the logic which is based on string. Okay, so that's the issue over here. Okay, understand why it
Okay.
is giving
Thank
the
you.
such output? You can think of
Yes.
going from a decimal point value to fraction, and you can think of applying that particular formula over here, and let's see whether you are able to do it or not, because that's a kind of different program which totally works on the mathematical aspect of this problem. Okay, yes, any other questions by anyone? Please do let me know, guys. So who will show it to me? Who will run it out and show it to me? Yes. Okay, if you want, I can. Okay, Rajkumar is saying he can show. No problem. Go ahead. Okay, I can see your screen. Go ahead. Okay, good. Okay, so you people can think of the logic. Okay, you people can think of the logic, right, and try to implement. If there is a different logic that is much better than this, you can try to implement that also. I don't mind in that. Okay. Anyone else would like to show me the screen? I would like to see at least two people's screen. I would like to see at least today that two people show me the screen. Two people have already shown me. Now, two more people I want to see. Not those who have already shown me. Okay. Yes. Either you people volunteer for it, or I will call your name. Okay, guys. So I stop the recording, and then if you want to show me, you can show me your screen. No issues. Okay. And if you have any questions, you can have interactions.